in this research project. So you are probably familiar with this project and different steps. So today Purya is going to, our lead PhD student is going to give a kind of summary presentation to conclude the entire project. So today I have also to watch my daughter, so but you don't hear anything, right? Because if I use the microphone, so we are good. Okay, sounds great. So Purya, can you please go ahead and if you have already prepared the slides, go ahead and share them with us. And you are still on mute. So if you unmute your microphone, you are good to go.
Sorry, can you see my screen?
Yes, we can.
Okay. Uh, Hello everyone. Good afternoon. My name is Priya Mohammadi. Today I'm going to explain our UTrack project and summarize what we have done in this project. The project name is Developing a Culvert Inspection Manual and Estimating Culvert's Deterioration Curve, Inspection Frequency, and Service Life for Utah culverts. In this meeting, first, I will start with an introduction to the project and discuss related works that have been done in this past. Then I will explain the culvert data pipeline that we implemented in this project, and I will go through the chapters of proposed culvert storm drain management manual system in more detail. And at last, I will describe the findings of the project as well as the limitations. So UDOT managed more than 120,000 culverts and storm drain pipes across the states. And therefore, UDOT needs a comprehensive culvert management system for tracking culverts condition and planning maintenance actions on these culverts. Since all the maintenance actions are depend on the results of inspection, we can say that culvert management system manual's key component is inspection of culverts. Usually, culverts are submerged or situated at a distance from surface, making it challenging to assess their condition. Culvert inspection takes a lot of time, energy, and money. Uh, Due to their location and their limited accessibility. To overcome these issues, we developed an efficient framework for UDOT to inspect culverts and that utilized a data-driven approach plus a risk-based prioritization approach. Using this framework, we proposed a culvert storm drain management system manual for Utah. There are various strategies that DOTs use for culvert inspection. Some state guidelines usually classify culverts by their span, such as Maryland DOT, North Carolina, Indiana DOT. Several state DOTs use culvert inspection policy depending on the culvert conditions and spans. Ohio DOT, Minnesota DOT, and New York State DOT are some of these examples. Uh, Researcher Migoda developed a decision support system for New Jersey DOT at 2017. Another researcher presented an approach for prioritizing culvert maintenance based on failure risk in South Carolina. And as a result, DOTs found that the inspection of culverts solely based on span and condition is not effective approach. So they decided to develop a decision support system for culvert inspection planning. Previous studies also developed a variety of culvert condition prediction models depending on the type of the target variables. Also, they use a variety of algorithms in their studies, such as decision trees, logistic regression, and artificial neural network. After reviewing the previous studies, I will explain the methodology that we have used for generating the culvert deterioration curve. So the developed Culvert data pipeline consists of three consecutive steps, as can be seen in this slide. In the first step, we have to collect data and transfer the data to our inventory. In the second step, we generated the deterioration curve for different states, including Utah, Vermont, and Colorado. And we identified the likelihood of failure from the deterioration curve for each culvert. And finally, we analyzed the failure cost of culvert to determine the consequence of failure for each culvert. After calculating the LOF, likelihood of failure, and COF, consequence of failure, we found the culvert risk factor, and based on the risk factor, we estimated the inspection frequency for each culvert to find, which is the objective of our project. Since Utah has a small data set of culverts, we added two states culvert inventory to our data set, Vermont and Colorado. The reason that we use these two data sets is the availability, and also UDOT provided the Colorado data set to us. So that's why we selected these two data sets. Now, let's summarize the data collection process. There were two main methods to collect data, using available data sets from another states or using available websites. As we mentioned, we collected Culvert data from three states, Utah, Colorado, and Vermont. Also, we collected road data and add them to data sets from UDOT traffic repository. In addition, soil data and Utah stream data can be extracted from available websites. The process of collecting soil data from Web Soil Survey website was done manually by inserting the latitude and longitude of each culvert. Also, UDOT can download the datasets and use them independently or integrate the dataset into their platform. As you can see in the slide, there's a picture of the website, and we have to copy paste the latitude and longitude of the culvert in this in the left part, and then we can see we can select the area of interest that we want the soil information of it, and then collect them manually. Similarly, Utah Streams data can be extracted manually looking for the culvert location on the Utah Open Data.js platform. You can see the address of the website and also the image of the website that we showed here, and the information of the streams at the location that the arrows showing pointing to. Uh, After Utah Culvert inventory had 272 rows that were collected during a other UTRAC project in 2004. And that's a small data set. And it's not enough for developing a machine learning model on it. So we added Colorado and Vermont data set to it. And the final data set contained 2,070 culverts. And in the data set that we used, there are several features that we consider. Uh, I'm going to read the features: culvert structure, culvert shape, culvert length, culvert inspection date, culvert installation year. These are the features that these are physical feature of the culvert, and soil pH, soil drainage class, soil moisture, soil electrical conductivity, flooding frequency are the environmental features that we have added in our dataset. The target variable that we are looking for is the culvert condition rating that we are using for prediction and for deterioration. In order to add the two data sets into Utah's culvert inventory, we have to first rescale the culvert condition ratings of uh, those data sets. Colorado uses a 9-point rating scale, and Vermont uses 7-point rating scale. After reviewing the description of each culvert, each rating, and the description of the condition that they describe in their manual. We assign this pattern for converting the scale and rescaling them, and then we can add them to our data set, and we have a 5-point rating scale for Colorado and 5-point rating scale for Vermont. After pre-processing the data, we have to develop a machine learning model. And we chose two algorithms here, as a support vector regression and random forest regression for the development. Support vector regression is a supervised machine learning model that supports linear and nonlinear regression. And random forest regression is a supervised learning algorithm for classification and regression, and also other problems that works by creating a large number of decision trees throughout the training. For after selecting the algorithm, we generated the iteration curves. Here is the framework for generating the iteration curves. First, we have to split our data into train and test. Then we have to train a model such as support vector regression on the training set and find the relation between the Culvert condition and Culvert parameters. Now the model is trained and we can use it to predict Culvert condition over years and fit a curve to the predicted condition to generate the iteration curves as shown in the figure. We estimated the iteration curves for each culvert separately and also for each type of culvert. And we developed a model based on the three data set together. After finding the iteration curve for the culverts, we can use the culvert age to find to predict the condition of the culvert in the future, and then we can use it as a likelihood of failure for the culvert. After finishing the iteration curve generation, we have to develop the risk-based prioritization method that we propose for inspection frequency. It is essential for approximating the inspection frequency using the risk-based approach. It is common to prioritize assets inspection, such as sewers, pipes, pavements, and bridges, based on their risk factor. Similarly, these projects, we are going to implement a risk-based prioritization to find the most critical culverts, and based on the estimated risk factor for each culvert, we can assign inspection frequency to the culverts. As you can see in the equation at the bottom of the slide, a risk factor is calculated by multiplying the likelihood of failure by consequence of failure. In other words, identifying the culverts with higher probability of failure may not be enough because we don't have the budget to inspect all culverts. So another factor called consequence of failure comes to play. For example, a culvert located under I-15 with lower likelihood of failure may have higher risk than a culvert located under rural road, but with higher probability of failure. That's why we need to focus on the bigger culverts located on main roads with higher annual average daily traffic to mitigate the risk of losing lives. In the following slide, I will provide details about likelihood of failure and consequence of failure. So likelihood of failure related directly to the current condition of the culvert. As the pipes age, the failure rate increases since pipes are more susceptible to erosion and abrasion. Several factors affect these parameters, such as pipe material, remaining useful life, repair history, soil type, and inspection rating. We have already established deterioration curves, and they can directly be used to approximate the likelihood of failure in different conditions. For example, in different studies, likelihood of failures are assigned to different conditions. They use different ranges, but they show similar concept. Some of them assign weights between 1 to 10, some of them between 1 to 0. We used one of them, which is 0 to 1, and the table that showed in the slide is the LOF that UDOT provided to use for this research. Using the generated deterioration curves and the current age of the culvert, now we can estimate the condition, and we can assign the likelihood of failure to a culvert. But for consequence of failure, it's different. Consequence of failure linked to the assets type and are categorized into economic and social factors. Economic factors include repair or replace cost and damage to a nearby properties. Since the real economic impact is composed of various cost items. Some studies have tried to estimate the cost using indirect approaches. For example, we can take the physical dimensions of culverts, for example, diameter or span, to approximate the repair or replace cost. Social factors include the loss of service cost, which is the user delay cost mostly. Similarly, we can estimate the user delay cost using annual average daily traffic of the crossing road, which I'm going to show, which is not, I'm not going to describe the equation in this slide, in this presentation, but it's available in our project. And we categorize the culverts after that based on their location. Either they are under the roadway or next to the roadway, which determines the risk to the road users. When a culvert is under the roadway, the consequence of failure is equal to repair cost plus direct damage cost plus indirect damage cost. But when the culvert is not under the roadway, the consequence of failure is only equal to repair cost and direct damage cost. These costs are not a real cost. These are these cost factors that shows which these are relative costs, and these are good for the prioritization, not for the cost of real failure. Finally, we multiply the likelihood of failure with consequence of cost cost of failure to estimate the total risk for each culvert. Based on the risk value that we found, we could assign different risk categories from A, B, C, and next action. And then the risk category and condition of culvert, we can generate the risk matrix to find out the risk level of each culvert. So here is the final result, which shows the risk matrix for 272 culverts that we have from Utah. And the last step is assigning the inspection frequency to culverts based on the risk level. Culverts in level 4 zone should be inspected every 10 years, in level 3 every 7 years, in level 2 every 3 years, and in level 1 every year. So till now, we described the culvert data pipeline framework. Now let's move forward and discuss the proposed culvert storm drain management manual for Utah. We reviewed several of existing culvert inspection and maintenance manuals, such as FHWA, AASHTO, New York State Manual, Ohio State Manual, and NCHRP. These manuals may have different layouts or chapters, but they mostly cover same concepts and provide the necessary content for the Utah Culvert Management Manual. Also, UDOT provided some of its documents related to inspection and maintenance of culverts that we reviewed them too. After reviewing these inspection manuals, this is the final outline of the manual that we proposed. Based on the literature review of existing Culvert manuals and recommendations from UDOT and specifically Abdul, we propose the following outline. The contents are, I will go through the contents in the following slides. In chapter one, we provided a basic introduction to the manual sections and highlighted the need of standardized inspection. Also, the objectives, audience, and organization of the manual is presented. In chapter two, we discussed the uh, inventory records and different characteristics required to be included in the inventory. In chapter three, we discussed the inspector, their duties and qualifications, equipment, and safety during inspection. In chapter 4, we talked about the culvert inspection procedure and provided information including purpose and scope of inspections, preparation and planning, types of inspection, types of entry, and inspection frequency, and inspection record forms. We included our proposed data-driven inspection method in section 4.6, inspection frequency. In chapter 5, we discussed about the UDOT rating system and provided a UDOT pipe defect rating sheets. And in chapter 6, we explained the repair and rehabilitation methods and discussed about capital improvement program and proposed uh, capital improvement program. And in chapter 7, we provide an alphabetic list of terms in or words relating to culverts with explanations. And in chapter 8 is the references that we used. Summary of and findings of this project. This research aims to assist UDOT in estimating deterioration curves of culverts in Utah and recommending culvert inspection frequency. Based on these curves, that we developed, we propose inspection frequency for culverts for each type of culverts. Another application of deterioration curves is predicting the service life of culverts to rehabilitate or replace them before they fail. The accuracy results of the machine learning model that we developed, SVR and RFR models, are 71% and 79% respectively. And these are good accuracy and these are satisfactory. These satisfied our uh, intention. We also developed a draft of Culvert storm drain management system manual for Utah using the proposed framework for inspection. The limitations and challenges that we go through during this project was uh, the performance of the models would be better validated with more data from Utah's culvert inventory. And since we have only 272 culverts data, it's a little low to validate our method, but can add more data to this for validation, and that would be great. Considering the data that were collected by humans, some errors could occur during the inspection of culverts. So we put some filter on the data based on the age and the condition. And as a result, the data that we use for developing ML models was a little smaller than what we collected. And then that's another issue. Uh, Here is the flowchart of the project. We completed generating the iteration curves for Utah State and other Colorado and Vermont, uh, as well as three states together. Also, we uh, propose inspection frequency based on risk-based analysis, and we develop a convert management system manual for Utah at last as a result of this project. And finally, I want to thank you all. Now I'm open to questions and feedback you have.
Thank you, Dr. Mohammadi. There are a couple of questions in the chat box, if you don't mind.
I cannot see the chat box. Sorry. Okay.
Yeah.
Do you see it now? Or?
Yeah, I'm seeing.
Okay.
Yeah, that's true, because first we have to inspect culverts, and then we can do prioritization role when we inspect.
Well, thanks for reading that. My comment is, this is a great process that you developed. But we can reduce the number where we start by prioritizing by natural hazard risk and cut down on how many we have to begin with. And we have a significant benefit in the reduction of risk by doing that. And then the other culverts that have some kind of risk, your process works very well. But 82% of the culverts, maybe we can just wait till we get around to them or till they fell. Because trying to inspect 150,000 culverts is going to be incredibly expensive and take a very long time.
So you are proposing that we should consider the hazards in the calculation?
I'm proposing that you start with known natural hazard threats.
So we didn't have enough information for the hazards in Utah, and
Well,
we didn't.
you don't, but we've done that. That's my point. It is on our risk map, and we've looked at it. And what we've seen is that if you limit the risk to 5% of the replacement cost of the asset, you can reduce the overall risk to flooding of culverts by over 50%. You only have to look at only have to start with 179 culverts to get that percentage of risk reduction. So that's where we should start. And your process dovetails very well into this. I'm not saying we shouldn't do it. I'm just saying, let's choose how we start.
Yeah, adding the hazards into the calculations would be a great idea. And the reason that we didn't consider that we didn't have enough data for the hazards. And if you have it and you can add this to our calculation, that would be great. And
yeah,
it
we do
more
have
efficient.
it. And we presented this to all 4 regions and asked them to validate the risks that we had found with our data and to start with those. Yes. So anyway, I like your process. It's very good. It's very well thought out. I appreciate it.
Yeah. Thank you. Yeah, go on, Jeff.
Hi, thanks for giving us that update. It was very detailed. I had a question with the likelihood of failure calculations. Is that something that you go into detail in the manual?
In the manual, we are not going to over likelihood of, the calculation of likelihood of
Yes.
failure is done by UDOT. We didn't do that. We didn't do it. We receive the numbers and we add them, and
Okay.
that's it.
Yeah, one of my thoughts, you're using soil, and I don't know what was going into that likelihood of failure, but it looked like you were looking at soil maps from the NRCS soil survey. And the question I have is the accuracy of the data, but when we construct our roads, we're bringing in material, we're bringing in import material, building up embankments. So most of these culverts or storm drains are not in the native soil. They're being constructed in imported materials. So I didn't know how sensitive that data was, or that calculation, when you're looking at soil types.
So the water, when it go pass through the soil, may include some contaminants that cause abrasion and erosion for the culvert. That's why we consider the soil data.
Okay, so it wasn't the soil surrounding the pipe.
We created an area of interest around the culvert, but it's big. So we consider the huge area, and that's why we can use that data. It's not
So,
exactly
Jeff,
on the.
thank you for the comment. Yeah, you are right. So basically the soil might be different, and we had this discussion, but it would be a little bit difficult to basically predict or evaluate the actual situation, what is going on with the actual soil or what type of soil is actually there. So we thought that's okay. So this is at least better than nothing. So we are considering the surrounding soil for the situation, but you are right. So it's not actually the exact soil that will be there, right?
Yes.
Any other questions for Dr. Rashidi and Mohammadi? Go ahead, Danny.
Yeah, I just had a quick question. First of all, guys, great work. That's a lot of effort that you put into this. My question is mainly focused around treatments based on condition states. I know in section 6.3, you provide a bunch of treatments. I was just wondering, based on that information within the manual, if there's enough treatments provided for the different culvert types that UDOT has. In other words, do you have something that we can take and provide guidance to the maintenance folks on how to repair a masonry culvert or a timber culvert? Even though we don't have many of those in our inventory, is there something that we could recommend to them as far as how to preserve or maintain or rehabilitate culverts of those types?
We reviewed several manuals of the other states and also H2, and we mentioned the maintenance actions that most of the DOT is doing, and we name them there. But the maintenance that UDOT can do and what we can propose to them is not definite here. Abdul and others going to work on the maintenance section and improve it, probably based on the Utah's condition, I think.
Okay.
Because it's only the draft and it will be improved.
Yep. Thanks.
Sure.
Any other questions? If not, Denny, we have some time. Is there any way, is this okay to, sorry to call on you, are you prepared to kind of share that MLOS effort, or we can, if not, we can leave it for next time?
You know what I'd like to do, Ab, is just kind of maybe really quickly, if it's okay with the committee, maybe have a discussion on a few points that we've been talking about within the MLOS that have kind of been something that we just need to get clarification on or greater information and just feel how the committee feels, if that's okay. And there's really only two areas that we just wanted to confirm, and you both made comments on them. So if it's okay, maybe I can just pull it up real quick. Here, let me share. I believe most of you guys have it, but let me go ahead and copy the link and I'll throw it in the comment section here. And then let me know when you guys get that, and I will share it with everybody. Okay. So this is just a section out of, let me share my screen. Sorry, guys. Pull that up real quick. So this is a document that we've developed, and maybe to give us some background for those of you who may or may not know. The maintenance level of service is a document that provides direction and guidance on the maintenance forces of not only how to rate a culvert, but also what the intended inspection frequency is that the folks from the U just provided, and we've kind of modeled that into our system. but also how frequently we need to get out there and do an inspection and the possible treatments. And this really helps us with cost estimating and coming up with what we call a work plan centered around our drainage and culverts moving forward with maintenance. Okay, so the one thing that I'd like to kind of discuss is this area right here, as far as what the requested frequency is as far as maintenance and the number of inspections that they want to perform. And we've heard some really good conversation about 5% that we talked about today. Rudy, you mentioned that, hey, look, you go out and do 5% of the culverts, you're talking several hundreds of thousands of dollars. So what we were trying to do is refine it in a way where we can tackle the most critical culverts first, but at the same time, start to gain more information on the inventory along with the condition of what our inventory is, because we understand that's kind of the piece that we're missing a little bit right now. And so the proposed measurement for the maintenance folks is 5% of all UDOT maintained culvert drainage pipes along all routes. So that was kind of what was initially put in there. And we said, well, let's provide some additional direction to maintenance. They're really sharing around one of two things. Number one is if you live, or if I'm a maintenance station and I happen to be in a very urbanized area, 5% of my overall culverts could be a significant number, which could result in a lot of costs that I may or may not be planning for. Vice versa, if I'm in a rural area, and I'm just going to use one for example, if I'm out in Wendover, 5% of my culverts could be maybe 5 or 10 and I'm off the hook. And so we kind of wanted to come up with a solution that would not only help balance costs, but also help us get to that 5%. So we just kind of, we came up with the following language, and I'd like to have a discussion here, if that's okay, Ab, based on what the committee thinks and feels is the right approach for maintenance. So the first bullet we have right here is, and I'm just going to highlight it. If I need to make this bigger, here, let me zoom up on this. Is all high-risk culvert / drainage pipes are to be inspected on an annual basis of an open